Hello, this video is on transformations of square root functions. You should have a note sheet to go with this so you can just fill it in as we go. Transformations of square root functions are actually super similar to absolute value functions. So a number under the square root symbol lies and it shifts the graph left or right. So that's the same as the number that would be inside the absolute value bars, how that one shifts it left or right as well. A number outside the square root symbol shifts the graph up or down. So that's like our k value. And a negative a value will reflect the graph or flip the graph, however you want to think about it. And it can also stretch our graph horizontally, so making it wider, or vertically and making it narrower. So let's just jump into some examples. Y equals the square root of x. This is our parent function. Remember, this is the one that has had no transformations done to it. It is kind of the base function, the base graph we compare everything else to. That is every other square root function. If you remember back to a couple units ago, we talked about the domain of square root functions. Remember, the domain of a square root function is really important because we're taking the square root of something, and we know we can't take the square root of negative numbers. So your homework assignment, your test is going to ask you for the domain of the function that's given. So remember, we just take what's under the square root, set it greater than or equal to 0. So in this case, our domain is just x is greater than or equal to 0. Sometimes we have to actually solve for x, and there's a little bit more work involved. So from here, we have our domain. The easiest thing to do, just like we've been doing with a lot of other things, is to make a table. You will notice that there are some patterns with this graph, just like with an absolute value function, there's some symmetry. You can use that to help you out as you're graphing if you want. So I'm going to start with x being 0, since our domain is x is greater than or equal to 0. If I plug that in, I get y is 0. I am going to intentionally pick some x values that work nicely. So my next value I'm going to do is 1, square root of 1 is 1, and then I'm actually going to skip to 4. So I'm choosing numbers that when I take the square root, I get a whole number. So then if I want to do more, I would jump to 9 and get 3. So I'm picking ones that work nicely. You don't have to. And then we'll go ahead and graph these. So 0, 0, 1, 1, and then 4, 2. And then 9, 3 won't fit on there. If you want to sketch about where it would be, you can. So it kind of looks like maybe half of a parabola if you turned it, but you only have that one half. We're not going to have any symmetry or any reflection with the square root function. Okay, next one is square root of x plus 1. So if you remember what we talked about on the very first slide, anything under the square root would shift it left or right. There's nothing else there, but anything outside of it shifts it up or down, and it's honest. So I'm expecting when I make my table and graph, it should be shifted up 1. Domain, I'm taking what's under the square root, setting it greater than or equal to 0. So domain is still the same. Go ahead and make my table. I'm going to start with 0. If I plug in 0, I get 0 plus 1. So that would give me 1. Plug in 1 next, square root of 1 plus 1. That's the same as 1 plus 1 is 2. Plug in 4. Oops, that should be plus 1, sorry. That would give me 2 plus 1, which is 3. And so on. If you wanted to do 9, that would give me 4. So 0, 1. We're at 1, 2. And 4, 3. So we can see it's got that same kind of curve going on as our first example, and the whole thing has just been lifted 1 up on our graph. Alright, on to our next one, square root of x minus 3, and that whole thing, the x minus 3, is under the square root. So this is one of those times where I might want to take what's under the square root, set it greater than or equal to 0, and actually solve for x this way. That's how I can find my domain now, so x is greater than or equal to 3. That's going to help us with our table. Now I'm going to think back to what I know. Anything under the square root, just like anything inside the absolute value bars, shifts it left or right, and it lies. So I'm going to predict that this is going to go, it's going to be shifted right 3. I'm going to go ahead and make my table. This time my table starts at 3 because my domain is x is greater than or equal to 3, so it can't be anything smaller than that. If I plug in 3, I get square root of 3 minus 3, which is square root of 0. Again, I'm going to pick x values that work nicely. So if I plug in 4, I get the square root of 4 minus 3, which gives me the square root of 1, which is a whole number, and it's 1, so it works out nicely. Next, I personally would choose 7. Square root of 7 minus 3 is the same as the square root of 4, which is 2. And then I would probably pick 12 and get the square root of 9, which is 3. So they're not all going to fit on there, but let's graph what we can. So 3, 0, 4, 1. That was a little off, sorry. And then 7, 2. So drawing my graph, I can see the whole thing, same curve, shifted 3 to the right. Okay, y equals negative square root of x plus 1 minus 3. So I have a couple things going on here. Let's start with doing our domain. Take what's under the square root, set it greater than or equal to 0, solve for x. We already had some practice doing this in one of our other units. So my domain is x is anything greater than or equal to negative 1. Good to know, that should help us with our table. Now if I'm picking apart my equation and I'm trying to make a prediction here, I know the negative symbol should flip the graph. That plus 1 underneath is going to lie, and it's going to move it left, so shift 1 left. And then that 3 is honest. It's going to shift it 3 up. Oops, excuse me, that's a minus. Let's back up. Minus 3, so it'd be down 3, because it's honest outside there. Go ahead and make my table. Again, once you guys do a bunch of these, you're going to see a pattern what the graph looks like. You maybe need the table, you maybe don't. I'm going to start at negative 1. If I plug that in, I get negative square root of 0 minus 3. So that gives me just 0 minus 3, which is negative 3. I'm actually going to plug in 0 next, so that gives me negative square root of 1 minus 3. Square root of 1 is 1. Then I apply the negative, so I end up with negative 1 minus 3, which is negative 4. Let's think. Next I'd probably do 3, because that would give me negative square root of 4 minus 3. So that would give me negative 2 minus 3, which is negative 5. And then if I was going to pick another one, I'd probably do 8, which isn't quite going to fit on our graph because it goes up to 7. So we'll use these ones to get started. So my first point is going to be at negative 1, negative 3. Okay, 0, negative 4, and 3, negative 5. So I can see it's got that starting point. If you guys haven't noticed yet, I'm only drawing my arrow in one direction. That's because I can't include any x values here that are less than negative 1. So my graph won't continue off to the left here. But it has flipped, so I still see that curve. Probably not as pretty as the one you drew on your paper because I'm drawing on my iPad. But we have that kind of half curve going on that doesn't have any symmetry or anything. So, alright, last one, square root of x plus 2 and then minus 4. Let's do our domain. So x plus 2 greater than or equal to 0. Some of you guys can maybe do this in your head, that's fine. X greater than or equal to negative 2. Transformations, well I know anything under the square root lies. So I'm expecting it to shift to left. And then the 4 also is honest and 4 down. Alright, let's pick some points. Start with negative 2. If I plug that in, I get square root of 0 minus 4. So that gives me negative 4. Next I'm going to do negative 1. So that gives me the square root of 1 minus 4. So that's negative 3. Next I'm going to do, let's do 2. So that gives me the square root of 4 minus 4. And think about what gives you nice whole numbers. So square root of 4 is 2 minus 4. So that gives me negative 2. And then from here I'd probably do 7, because that would give me the square root of 9 minus 4, or 3 minus 4, which is negative 1. So now I've got some points to graph. I'm going to start at negative 2, negative 4. Then I'm at negative 1, negative 3, 2, negative 2, and 7, negative 1. I would say it's nice if you can have 4 points on a graph, but sometimes they don't fit. So 3 is kind of the minimum, but obviously more is better. Thanks for watching.